All right, hello, welcome. I would like everyone who is attending the workshop to sit down, and then to all the Codex team members to stand up. I will introduce you, if that's okay. So, we have Tomas, we have Arno, this is Chaba, Marine, and the man pushing the buttons today is Eric. My name is Ben, I will be talking and pointing at things. And I would like to say thank you very much for being here. It is an honor and a privilege to be here talking to you about this. So what we're going to do today is we're going to start sort of like a presentation. This shouldn't take too long or be any more painful than strictly necessary, but there are a few things that we should explain first. So we'll talk to you about the Codex project. What is Codex? Tell you a little bit about how our marketplace works. Then an overview of the setup of the workshop. So you brought your laptops, you can just follow along with the instructions that we'll be giving you. And if you don't choose to follow along, that's fine. We will be doing the instructions ourselves on the projector so you can still see, how it works and sort of works and what it can and can't do. So, first of all, this is our team. You can find us at codex.storage. Anything that you would ever want to find about us, you can find via codex.storage. We've got GitHubs and Twitters and Discords and whatever. So just go to codex.storage. You can always connect with us further. Very handy. Codex is, so what is it? We are a storage network. We are a decentralized storage network and a protocol. We focus on data durability and censorship resistance. Among other things, it has a whole bunch of features in various states of completeness and research. Some of it's implemented, and we're going to be playing with that during the workshop with our implementation so far. So like I said, we have durability as a focus point, censorship resistance, we're decentralized, we're accessible or permissionless. So anyone can join the network either as a provider of storage or as a purchaser of storage. How this works exactly is a long story, but very broadly speaking, we combine peer-to-peer data exchange with a storage, a market for storage guys. So I suppose you all know when I say peer-to-peer data exchange, I don't need to explain that much further, so we will zoom in a little bit on the marketplace. So let's say we have some nodes, we have these circles, these are nodes, right, in the network. And we have some blockchain down here. I'm not going to say which one, but it's something that's like running our Solidity scripts that are like doing the smart contract. So the nodes, I turned them teal here. These are the ones that have space that they wish to sell. We'll call them hosts. And then we have a yellow one over here that has data that it wants to store in the network. We'll call those clients to keep it simple. So here it has some data. You can't really see, but these are three little blocks of like original data. And the client wants to store it in the network for a certain period of time for a certain price. They're willing to pay a certain price for the storage, for this service. So how then does that work? The first thing that the client will do is we'll generate parity data, this data right here. So it'll generate 3 more blocks of data. And to explain it very simply, what that allows you to do is if you have any 3 of these 6 blocks, you have the original data. So either you have the original data blocks or you have one of the parity blocks or a bunch of parity blocks, and you'll be able to reconstruct the original data. So that makes it more durable, right? You need 3 of these 6, any 3 of these 6, and then you can get the original data. So that's very nice. You can then, the client will then host the contract for storage on chain, and will pay the price for the duration for the service for the storing of the data. We'll pay it up. This goes on chain, and the hosts who are there monitoring this chain, they notice this event on chain, and what they will do is they will look at that contract and they will check it against their own resource availability. So they will check like, how big is this data? How long does the person want to store it? What are the durability requirements? And also, is this even lucrative? Like, is there enough money in this deal that it's interesting for me to join this contract? So these 3, for obvious reasons, they decide that, yes, I want in on this contract. This looks like a good deal. And so then what happens is we cut the data into what we like to call slots. And the slots are formatted in such a way that they have a combination of original data and parity data in some ratio. And then each slot is distributed to the different hosts. You might figure out already why we would do it that way. This is so that if any hosts fail and disappear from the network, then the data can still be reconstructed from the data that's available on the other host. So the host will download the data from the client, and then they will generate a proof of storage. So we have like a circuit, zero-knowledge circuit. I'm not sure if it's zero knowledge, but at least it generates proofs. And the host posts those on chain along with collateral. So they post collateral in the form of some tokens with some value that they lock it into the contract. And from the moment they do that, so I didn't draw all the arrows here because it would be really busy, but all the hosts post the proof and post the collateral. And the moment that a host does that, they are on the hook for storing that bit of the contract, that slot from the contract, for the duration of the contract, though, right? So what that means is that during the duration of the contract, at some periodic interval, they'll be required to submit proof that they still have the data and that it's in good condition and that they are indeed online and on the network. So they submit the proof of storage, and should they fail to do that, then their collateral can be slashed. Should they repeatedly fail to do that, then the data might be in jeopardy. So then we consider that slot that the host was supposed to be filling, but the proofs are missing, that slot becomes available again, right? So the host is removed from the contract, the slot's available again, and new hosts can jump in to fill the vacant slot, repair the data using the earlier explained mechanism, so that this helps you repair the data, and this enhances the durability considerably over longer periods of time. So sometime later, the client can come back into the network and fetch the data. Obviously, anyone in the network can join. You can join and fetch the data if they have the correct identifier, but the client being the one who originally uploaded, they have the identifier, so they can always get their data back while the contract is running. At this point, it's good to know, when all the slots in the contract are filled by a host, then they have all posted proof, they have all posted their collateral. At that moment, the contract is considered started. The contracts, they go through several stages. First, they start submitted, and all the slots are filled, it's started, right? And sometime later, because that's sometime even later, the contracts have a duration. So at some point, the time for the contract runs out, it's finished. So the contract then reaches finished state, and the hosts are able to retrieve their collateral, and they'll get the payment for the services they render. Right? So if anyone has any questions about this at this point, this would be a good time to ask. 1 Mississippi, 2 Mississippi. All right. So what we can do in the network, in the workshop, is we'll show you how to set up a node and join the network. We can do that right now. If you have a laptop and this sounds like fun, then you're invited to join us. We'll show you some basics, like how you get some information about the status of your node, which is good to know. You can upload an image to the network. We'll download an image from the network. Then we will show you how to start a request for storage, to store your image on the network for some duration of time. And then we'll show you how to get the status information of this purchase. Because like I said, the contract goes through several states, and it would be very nice if you could see how the data is doing. So we'll be doing that. If you notice there's one thing suspiciously absent from this list, it's that we won't be showing you today how to run a storage node. That was like a technical consideration. It's not all that difficult to do that, but it requires a zero-knowledge circuit, and it requires some other computational machinery, and it's totally doable with your consumer-grade hardware, because you have devices over there that are going to be the hosts for our workshop, so it's totally doable on your normal hardware. It's just, for the workshop, we decided maybe it's better we leave that one aside for the time being. But if you're interested, you want to do that on the online network, there are plenty of instructions to be found in all of our data. Just go to codex.storage, and you can find it. So this is the setup that we have for you today. We have a local network, that we're running right here. It's just a Wi-Fi that you can connect to. And then on your machine, we'll run a Codex node. The Codex node has a web API that we'll be talking to, and it'll make a directory where it'll store all its data. And we'll give you a bunch of curl commands to talk to your node. But if you have some other tools you want to use to do the commands, that's also very possible. We provided some machines, we brought these. There'll be a bootstrap node that will connect to. It'll hook you up into the local network. And then we also have a bunch of storage nodes here running with very lucrative configurations. So if you post a request, then they will pick it up and they'll fill the slots for you. The one thing that we don't have local, this is what we're borrowing from our public infrastructure. We have a get node running. It's running an Ethereum chain in proof of authority. So we're running that one, and it has our smart contracts on it. So we'll be talking to that to moderate our marketplace sales and purchases and whatever it needs to do. To buy the storage space during the workshop, you'll need some tokens, right? And you can go to either the Discord bot. We have a Discord bot. You join our Discord server. You can ask the bot. It'll give you some tokens. Or we have some faucets set up. Links to that will be provided. Don't worry. You just ask either of these things. It'll give you some tokens. Get right started. So if you're ready to start, please choose an image file, just a picture, something that you don't mind the internet having, because this is going to go onto the network and then other people might end up with it on their computers. So pick a nice picture. It should be maybe more than 1 or 2 megabytes, just something that's a little spacious. If it's too small, then some of our proving things might run into trouble. So something between 2 and 10 megabytes would be ideal. And if you have that ready, then we can go to the instructions. So you can punch in this URL, or you can scan this QR code. It'll take you to an MD. These are step-by-step instructions. You can run them at your own pace, just however fast you want to do them. If you run into trouble, just raise your hand. There are plenty of Codex people around. We can help you out. If it doesn't work for some reason, we'll take a look. And if you're not that interested in going through the steps by yourself right now, we will also be doing the workshop ourselves here on the screen. So you can just sit down and watch if that's what you prefer. All right. Anyone, any questions at this point? Really? Yes, sir.
Why is there a less than 10 megabyte restriction?
The less than 10 megabyte restriction is just for the sake of speed. Yeah, so it doesn't take us that long to transmit data. So we weren't sure how many people were going to show up or how many people were going to join. And so if we start filling the network with several gigabytes of data, then it'd probably work. It would just take a while. So it wouldn't be all that interesting. All right. Eric, you want to get started? All right. Maybe zoom that in a little. I'm going to put this thing down. All right. So the first thing that you should do, get onto our network. It's called Codex. Password's right there. Very inventive. We'll put a couple of instructions on the screen all at once. So the next step is to clone this repository. If you follow the link, then you have this on your screen. You can just copy paste it. You gonna do this? Do you have it already set up? Yeah, go ahead. Well, that's maybe a bit small. Over. Is it working? All right, can you zoom this in a little, because I'm imagining it is. Can you duplicate your screen, man? Can you duplicate it so it's the same on both? or that. Can you zoom in the terminal a little? Yeah, that's probably better. All right, so this is a repository that we set up. It just has a bunch of scripting in it, helps you get started very easily, right? So it has a script that will download Codex binaries for you. You can compile it from sources, of course. The sources are available. You can, but we figured we had 2 hours for this workshop, and if we asked you all to install the entire dev env, then we can lose at least half an hour, maybe 45 minutes, maybe an hour before most people actually had the binaries. And that's not the point of this exercise. The point of it is to run the thing, not to spend most of the time building the thing. So we just put some binaries for you. Yeah, there's a download script right there. It'd be hilarious if this failed right now. Just step one. Okay. We got it? Yeah, okay. So the next thing we'll do is we'll generate a key pair. You're never going to use your actual public and private key for a workshop like this. So we just run the generate. It generates a private key and an Ethereum address. It saves it to files for you, right? So the next thing we're going to do, I don't think we're not going to mint yet, are we? We're going to make sure. So this key file that we got right here, Codex will read that, and it will derive the address, and that's the tokens that are on that address is what it will use to transact, automatically. So if you send Codex the instruction to purchase storage for you, it'll use that. But also if you rig your Codex to sell space for it, it'll be using the same address to receive the rewards for it. So yeah, the next step was to run the client. So, okay, here's a thing that you should, okay, so if you're on the local network, you will have an IP address with 88 at the third place. Here, 88, right? If you run the script and it doesn't show a local address like this, then you're doing it wrong and it's not gonna work. So you might wanna at that point stop and you just set the local IP variable and then you can try it again. There are instructions on that in the document for sure. But in most cases it should work, but in case it doesn't, if you run it and later on it doesn't work and then check this, that might be a problem. Yeah, there's some instructions and something you might need for your distro or other operating systems, different requirements. All right. Yeah, there's how to override the address. Okay, we're gonna acquire some tokens. So we just created a new address. We're gonna send some tokens to it. You can do it in one of two ways. You can use the faucets, or you can join our Discord server and use the bot. Either way, it's pretty damn convenient. Just go to the site and you paste in your address. It takes a while sometimes. Yeah, it looks like it. Yeah, you paste in the address, and then you claim your rewards. You wait a second, it takes a moment before it's included in the chain. Up to 12 seconds or something, I guess. All right, so you get 10 ETH. This is not really ETH, of course, this is just on our stupid test chain. And you get 10 TST, which is just our test token. But that's what you will use to transact for storage in this network. So it's just what you need. All right. So once you have Codex now we have Codex set up and it's running. So we go to another file where you can find some instructions on how to use it, how to get your first hello world out of the application, basically. So if you want to run this thing at home and you have it set up on your home network and you have your ports forwarded and all that, then you didn't need this part of the instructions, but these will still work. So how to use the Codex will be the same. So first thing we'll do is we'll just send this debug info command to Codex, and it just gives you a whole bunch of status information about your node. It's how is it connected? Is it seeing other people in the network? And if there's connection trouble, then you run this command and it's a good chance that you can see something wrong with the configuration and it'll help you fix it. right? So it looks like this is a whole bunch of JSON, right? So the thing I want to point to, hold on a second. Right here you have announced addresses, right? There's that 88, that local address again. If that's not there, you're doing it wrong, right? Okay, so that's what I wanted to say about that. Here's a bunch of information about other nodes and whether you've seen them, and they can reach you in the network, so that's good. Yeah, these are the peers in the network, right? You have their IDs. All right, so the next thing we'll do is we'll upload that image that you picked at the beginning of the setup. So we'll have an image, or we make an image. Something cool, cute cats.
Can I get a volunteer?
Anyone, any input? What are the cats doing?
Fishing. Ah, I like that.
We lost it. Oh, you need to put it on the images.
I think you have to log in. Right.
Yeah, hey there. Oh,
Yeah, that's because of me.
Marv, what did you do?
I deleted all the credits.
Oh no.
No, but that's still. Tell you what, we'll just go to Google and see what the cats fishing. There we go. More AI.
All right, so is it big enough? Probably, maybe. I have no idea what that is. Oh, I like that one.
File size like.
You could, I think you could say large or something. Oh, nice. Cat fishing. Sure, why not? All right. All right, there it is. How big is that? All right. So we'll use this fill command, but like I said, you can use any tool you like. We also have, it's good to mention, we have an open API YAML file for this API. Lots of tools or code generators, you can just load it right in and it'll generate everything for you. You can start using your Codex node with that right away. But we have some drill commands prepared. We just put the file into it. All right, so after you upload a file, you get one of these. These are CIDs, they are content identifiers. If you upload the same file, you get the same CID. They're like sort of hashes. It's a bit more complicated than that, but it has a lot to do with hashes. So if you have the same file, it has the same CID. Now we'll take that CID and you can give it to someone else in the local network. And if they have that CID, they can use it to download your file from the network, right? So after you've uploaded the file to your node, anyone in the network can get to it if they have the CID. So if you don't want them to have something been uploaded, or at least thoroughly encrypted first, and if you want to download something, then the command looks something like this. So you put the CID in the request right there. It's a JPEG. That'll still work, won't it? All right, so we go back to the node, we have the same CID, we put it in, we get the data back down. Sure, this is surprising absolutely nobody that this worked. Yeah, but it is important, you know. No point in storing your data if you can't get it back out, so. Excellent. All right, so at this moment, you have your node in the network, it's storing your file, and what we're now going to show you is how to make a request on-chain for the storing of that data. So we're going to spend some of those tokens and put a request on the chain for other people to store the data for you for some length of time. So, I fully forgot this is here. Okay, so when you run a node, it's nice to be able to see what data the damn thing is storing. So we have a command for that as well. You just paste that in, right there, and it'll show you if the syntax is not incorrect. I don't know where you were running the node thing. Okay, someone accidentally closed their node. 1 second here. These things, they happen. All right. And we're back. Maybe. Sort of. Yeah, is that correct? You can run oh, here we go. You didn't press enter properly. All right, so this is a bunch of unformatted JSON, but what you can see, right, is that you can identify the data sets that are currently being stored in your node. And what you'll see is, okay, we'll make it fancy. What you'll see is if you rig your node for storing data from contracts on chain, then other people's data sets will just sort of magically appear in here when your node decides to pick up a contract and start earning tokens for it. So yeah, this is just another way to keep an eye on what your thing's doing. So then the next one is about creating the request. So here's the instructions for making availability. So if you want to sell your space, you use this one. We're not doing that now, here, for previously mentioned reasons. But these are the instructions how to do that. But we are going to do is we're going to purchase some storage. So we use the CID again to identify the data that you want stored. And then there's a bunch of parameters I would like to explain for a minute. All right, CID is still set. Okay. So we have a bunch of parameters here. You can click this link, you get a whole bunch more information about it, but very briefly,